Good morning, students. So today we are going to see the electric cost of the particular uh, electricity generation cost and the points which are remaining in this particular chapter. So as we started, we in the last lectures we saw the different factors which are affecting the generation of the electricity, then the load curve, load duration curve. What is the difference between load curve and load duration curve? Because these two are very important whenever we plan to install any particular power plant, right? Because the whatever the installment or the whatever the planning, and if you want to design the capacity, design the plans of particular capacity, first we must know what is the demand. Okay, what is the requirement of the customer? How much electricity we must generate to satisfy that particular demand? And for that, the drawing of load curve and or we can say the load duration curve is very important. So the load curve will gives you the requirement at that particular instant of time. Whereas the load duration curve, it will show you or it will help you to select the particular type of generator. Okay, means it will generally give you the load duration curve will generally give you the maximum demand. So based upon the maximum demand, you can particularly use or you can select the particular type of power generator, right? What should be the capacity of that particular power generator, maximum capacity? That you can select or that you can find out by using the load duration curve. So first of all, we will draw the load curve, and based upon the load curve, we are going to draw the load duration curve. Okay. Now this load curve is again going to vary with respect to customer. It will vary with respect to season wise, or we can say the weekly also it will going to be vary. So it is particularly based upon the type of customer to which they are providing the maximum amount of electricity or the power, and also it is depends upon the time. Okay, it may be depends upon season, it may be depends upon months and other factors also. So this load curve we will going to draw for one particular customer, and based upon that we can calculate the other factors like the capacity factor of the power plant, than the maximum demand, etc. Okay. So numericals based upon load curve and load duration curves are very important. These are the important regarding the your MSc mid semester examination. Okay. Now in today's lecture we are going to we are going to take the next factors which are electric power generation cost. Uh, 1 minute. So the electric generation cost that we are going to see in this particular point. So as we know, to generate some electricity, there must be some input should be there, and there must be a cost which is related to the electricity generation or the power generation. So generally, the total cost of this particular electricity generation we can divide it into the two types. The first one is the fixed cost, and second one is the operating cost. So as name indicated, the total cost or the total what we can say the cost required to generate one particular electricity, that is depends upon the which type of power plant we are using. Okay, which will be the what will be the input to generate that particular power. So it is based upon many other factors also, but broadly we can classify those total costs into the two types, that is the fixed cost and the operating cost. Okay, so these costs are often which are expressed in unit currency per kilowatt of hour per our power produced. Means we can say this is the cost which is per unit of electricity generated. Okay, as we know, the unit of electricity which is provided in your home, in factories, those are in units, right? Or we can also call it as a kilowatt hour. Okay, 1 kilowatt hour is equal to 1 unit. So the cost will be again calculated based or per kilowatt hour or per unit of electricity generated. Okay. Now the first one is the fixed cost. As we know, the fixed cost also considered or consists of different types of the cost. First one, that is the land, building and equipment cost. Now this particular fixed cost is, we can also call it as the capital investment. We include the capital investment. It will include the other investment like the purchasing of the devices and other types. Okay, so the fixed cost again consists of the different types or the different costs. That is the land, building and equipment cost. As we know, to install one particular power plant, we require land. Okay, so the cost of the land, purchasing of the land, building, construction of the building, okay, required much more money than the equipments which are important to generate the electricity. Those are came under this particular type of the cost, and it will again the fixed cost, because again these costs, land, building and equipment costs, is also depends upon the required planned capacity of the power plant. If the capacity is very high, we require more land, we require more equipment. Okay, capacity of equipment must be the more. So in that case also it will going to be increased. So it is directly proportional to the capacity of the power plant. Okay. The next one is the interest, right? So whatever the capital we required or the capital cost we required, uh, generally it is borrowed from the particular bank, different banks, or it may be borrowed from the government. So the interest will be there. Interest will be there on that capital, which is borrowed from the government or from the bank. Okay, because the cost of the power plant, any particular power plant, it is in the billions, right? It may be in the millions of dollars, it may be in billions of rupees. So in that case, one single person cannot uh, privately fund this particular power plant, right? It is very difficult. So in that case, the to construct that particular power plant, the money will be borrowed from the government with low interest, or it may be borrowed from the different banks. It may be a World Bank, it may be a different private bank, or it may be a state bank. So on that particular capital, there will be an interest, right? So it may be annually interest will be present. So that is also came under the fixed cost. Then next one is the depreciation cost. So depreciation cost, it is also related to the life of the power plant. As life of power plant will increases, the cost of that particular power plant is going to be decreased, because as time passes, we are using that particular device. Consider there is a generator or turbine generator couple or turbine generator device is there. So over the time we are using that particular devices. Now as we use that particular devices, its cost will be reduced, goes on reduces, right? So similarly, whatever the cost of the power plant, total cost of the power plant, it will be depreciated with respect to time. Okay, so whenever we depreciate with the cost of the power plant depreciate with respect to the time, uh, so in that case, we have to make arrangements so that after some time, when the that particular power plant is not workable, okay, in that case we can provide one particular or we must have that much of money, so we will install the new power plant. So for that, what we do, for 1 year or during the 1 year or per year, we separate or we save the money. Okay, we kept some money from the profit from the power plant. Okay, and that money has been stored, or we can say the saved money, it has been used to construct the new power plant when the life of this old power plant has been over. Okay, now consider there is a one thermal power plant. The basic, the life which is given during the construction, that is the 10 years. Okay, just we are considering 10 years has been used. The life of power plant is 10 years. After 10 years, we cannot use this particular power plant. Now, what we are going to do, after 10 years, we have to construct new power plant, right? So for that, we require some capital. Okay, for that, we require some fixed cost, land cost, building cost, or the equipment cost. In that case, what we do, we just, in that case, what we do, per year, in this particular 10 years, per year, we are going to save some amount or kept some amount from the profit. Okay, so from first year we kept some amount. Okay, X amount, X rupees we are keeping saving that particular amount. After in second year also we are keeping some amount side or we just save that particular amount. So after 10 years, what will happen? We have some amount, okay, in savings, and this amount has been used to construct the new power plant. Okay, so from the profits we are saving some amount or some money. Okay, and that money has been, after 10 years, that money has been used to rebuild that particular power plant, or it may be used to replace the equipment, or it may be used for the expansion of the power plant. Okay, so that cost which has been kept aside from each and every year, that is called as a depreciation cost. Okay, and that depreciation cost, it again depends upon the total cost of the power plant. It may be varies with respect to the type of power plant. Okay, because generally the coal-based thermal power plant, its capital cost is very high, right? Whenever we compare it to the diesel-powered power plant or diesel IC engine powered power plant. Okay, so in that case, its depreciation cost is very high in the case of thermal power plant, in the case of hydroelectric power plant. Okay, but it is very less in the case of diesel engine based power plant. Okay, so it is totally depends upon the type of power plant, what is the profit we are gaining from that particular power plant. Now you can calculate this depreciation cost with using by different methods. Okay, the first method which is generally used, that is the straight line method. Okay, it is called as a straight line method. So from this particular method, we can find out, or we can find out the depreciation cost based upon by using this particular formula. Now, what is the A? A means the depreciation cost. Okay, that we have to find out. Then P is the initial investment, total initial investment to construct that particular power plant. S means salvage value, or we can simply refer it as a scrap value. Means after 10 years, if we sell that particular power plant, okay, or if we sell that equipment, what will be the value we will get for that particular equipment? So we can generally say it is a scrap value, that is the S, denoted by S. N means the life of the power plant. Okay, it is in the years, and R is annual rate of compound interest. So this is related to the interest value. Now, by using straight line method, you can directly calculate the particular depreciation cost. That is, A, depreciation cost is equal to initial investment minus scrap value or salvage value divided by numbers of years. Okay, so just consider in the new power plant which are going to be installed, it's having the value 10 crore. Okay, it may be very high in real life. Just consider it is the 10 crore. Okay, and after 10 years, its salvage value will be 2 crore. Means after 10 years, if we sell this particular power plant, we will get this scrap value equivalent to the 2 crores. Okay. Now, if you want to find out the depreciation cost, means after 10 years, we require 10 crores to build a new power plant. So in that case, we can kept aside some amount every year. So after 10 years, we have 10 crores in our account or in our savings. So for that, we can calculate this depreciation cost. That is, A is equal to this initial investment minus depreciation salvage value, that is, or we can say this scrap value, 10 minus 2 divided by the numbers of years. That is the 10 years, that is the life of that particular power plant. So 10 minus 2, 8 upon 10, their depreciation cost will be nearly 0.8 crore. Okay, it is the 0.8 crore, or we can say the 80 lakh. Okay, so each and every year we have to keep aside 80 lakh from the profits. So after 10 years, in the balance we have total 10 crores, and we can easily install the new power plant. Okay, that is a simple straight line method. For that, you can use this formula. Now, the main disadvantage of this particular method is that we cannot considering any inflation. Okay, because after 10 years, the construction cost or capital requirement of that particular power plant is very high, right? It may be 15 crore or it may be 16 crore. So we are not considering that. So that is the one of the basic disadvantage in this particular method. Now another disadvantage we can consider is that as life of plant will increases, the profit coming out from that particular power plant is also going to be reduced. So it is not possible for us to always kept aside or always taken out this much of amount from the profit, because in first or second year, first 3 or 4 years, there will be a maintenance cost is very less. So in that case, we can keep aside this much of amount. But as the life of plant will increases, it is very difficult to keep aside or even gaining that much of profit. So that is the some of the disadvantages of straight line method. The another method we can use, that is the sinking fund method. Okay, so the difference between the straight line and sinking fund is that the in the sinking fund method we are considering the reduction of profit with respect to life of the power plant. So based upon that, we can reduce the amount of savings with respect to year. Means in the first year we will kept aside more money, and as the life of power plant will increases, the amount of money we saving, it is going to be reduced, because at the same time the maintenance cost is increasing, right? So this is considered as a sinking fund method, and the related formula it has been given here, that is A is equal to under root in bracket R upon 1 plus R raised to n minus 1 into P minus S. Okay, here also we are considering the interest required to fill up. Okay, and the third one, that is the diminishing value method. It is again related to whatever the disadvantages straight line method is having. We are just avoiding that. Okay, so these three methods you can use to calculate the depreciation cost, and you can save that much of money each and every year. We keep that much of money aside. So after 10 years, after complete life of the power plant, we have some capital to build a new power plant. That is the again came under the fixed cost. The next fixed cost, that is the insurance. Insurance, as we know, it is very important because the cost of the power plant is very high. So in that case, if there is anything happens to the power plant, there may be backed by the insurance. Okay. The next one is the management cost. Now, management cost in this particular cost, it will consider we have to consider the planning cost, than the whatever the salaries which are given to the different management staff, etc. Okay, so those all came under the fixed cost of the power plant. Okay, those are the fixed. It is not depends upon the capacity of the power. It is roughly depends upon capacity of the power plant, but it will remain constant during the whole life of the power plant. Now, next classification or the next type of cost is operating cost. Okay, now this operating cost, we can say it is variable cost. Okay, because it is this operating cost will consist, one is the fuel cost and second one is the oil, grease or water cost. Means whatever the consumables are there, those cost cost of the consumables come under the operating cost. Okay, because regularly this much of some amount of fuel we required to generate the electricity. Similarly, during the maintenance we required oil, grease or grease type of the consumables. So whatever the cost related to this fuel, related to the maintenance, it is called as the operating cost. To operate the power plant, we required some cost, that is called as the operating cost. Okay, and it is most of the operating cost which is for the fuel cost, which is related to the fuel cost, right? Because to generate some electricity, we require some fuel. In the case of coal-based power plant, we required the coal. In the hydroelectric power plant, we require the water. Okay, water is the working medium, so we require the water. Then again, the maintenance cost will be there. Okay, different maintenance cost will be there to carry out the maintenance of different devices. Okay, so that is called as the operating cost. Now, the total cost is sum of the operating cost and the initial or the fixed cost. Okay, so you can also see the graph. which is gives you the idea regarding the investment efficiency with respect to the cost. Okay, or we can say the cost versus investment graph. And here you can see the fixed cost will be increases linearly as we increases the capacity of that particular power plant. Or if we increases the investment increments means what? The capacity will be increases. Okay, so as capacity of capacity of that particular power plant will increases, the annual cost will increase. Okay, that is regarding the fixed cost. And the second graph you can see that is the operating cost. So as we increases the efficiency, the annual cost or whatever the cost, operating cost will going to be decreases. Okay, because as we increases the efficiency in cost, we require less input to produce that particular power. So in that case, the as we increases the efficiency, operating cost will decrease. So if we combine these two costs, we will get the total cost, and you can see the variation of the total cost with respect to efficiency. Okay, and at this particular point, that is the point where we required minimum cost. Okay, and that particular point, as we can find out through the geometry, these the slope of these two graphs will be the same. Okay, slope of the operating cost graph and slope of the fixed cost graph will be the same. Okay, so by using this equation also you can find out the total cost, minimum total cost. Okay, it is minimum or we can say the optimum total cost required for the particular power plant. Okay, so this is regarding the electric cost. Now, whatever the tariff methods are there or whatever the tariff of electricity which is generated, it is based upon this total cost. Okay, so that is also we are going to see. Now, next point, that is the performance and operational characteristics of the power plant. Now, whenever we going to select any type of power plant, the performance of the power plant is very important. And what are the operational characteristics? Because the efficiency of the power plant, how that efficiency will vary with respect to the load, how it will vary with respect to how the input requirement is vary with respect to the load. It is very important because directly this will going to be vary the total cost or the operating cost of the particular power plant, and it is indirectly affect the tariff of that particular electricity or the power generated inside the power plant. Okay, so for that you must know what is the performance and operational characteristics of the particular power plant. In that, particularly we are going to concentrate on the input versus output graph, efficiency versus output or the load graph, than the heat rate versus output or load graph. Okay, now you can see in the first graph, that is the input versus output graph. On y-axis there is the input, on x-axis there is the output, and as we saw that is the parabolic curve. This particular curve is a parabolic curve, and as we saw, as we increases the output, the input required is also going to be increases. Okay, initially the increment or the slope of the graph is less. As we go, as we increases the input, this graph will be again increases. Okay, the slope of the graph will be increases. So it is a parabolic graph. Whenever we increases the output beyond certain limit, we require more and more input. Okay, more and more input we have to require. So how the input requirement is vary with respect to the load, that has been find out by using this particular graph, and it is important, right? Because as we if the load will be increases, as demand from the consumer or the customer will increases, input is also going to be increases. So in that proportional, we have to must keep some fuel should be available, and that much of input must be available, right? So that variation has been given by this first graph. The second graph, that is simple efficiency versus load curve. Okay, so you efficiency versus load curve. Here we can see as output or the load is varying, how the efficiency is going to be varying. Okay, and this is also again the parabolic curve. As you can see, initially as output will increases, the efficiency is also going to be increases. It will attain the maximum value at particular output value. Okay, this one is the maximum efficiency value at this particular output or the load. and beyond that particular value, efficiency is going to be start decreasing. Okay, so that is the variation of efficiency. We mostly try to run the power plant at the maximum efficiency point. Okay, but practically it is not possible. Practically, it is very difficult to sorry difficult to run that particular power plant at maximum efficiency, right? So in that case, we are going to we are uh, start or we are try to run that particular power plant near to the maximum efficiency. Okay, so that variation it is given by the second graph, and the third variation or the third graph which is related to the heat rate versus input or the load curve. Okay, now first of all, what is meant by heat rate? We know efficiency means output upon input, right? It is the output upon input, means this much of output we will get this much of unit. Generally, output will be mentioned in kilowatt hours, or we can simply call it as a electricity unit. Okay, that is kilowatt hour. That much of kilowatt hour will be generated. That is the output of the power plant. And what is the input? Input maybe in the case of hydroelectric power plant, it will be the discharge of the water. In the case of coal-based power plant, it is the amount of fuel or the amount of coal you are used. Okay, so that is the efficiency. Now, heat rate means what? Heat rate, it is the amount of input, or we can say the amount of energy which is used to produce 1 unit of electricity. Means how much amount of energy we require to generate 1 unit of electricity or 1 unit of power. Okay, that is known as the heat rate. And if we saw, efficiency and heat rate are universally proportional. Okay, so you can see heat rate we can find out input upon output. Okay, means or we can also define it as the amount of input or amount of input energy required to produce 1 kilowatt of electricity or 1 kilowatt of power. Okay, that is given by that is known as the heat rate. Also, its variation is the parabolic. You can see the variation of heat rate with respect to the load or demand. Okay, now the heat rate must be the minimum. Okay, because as we know, as is definition is there, we must require less and less amount of input. Okay, so as heat rate will be the less, that will be the beneficial. Okay, in the case of efficiency, efficiency should be maximum, whereas heat rate should be minimum. So that's why you can see this is the point where the heat rate is very less. Okay, or the minimum heat rate is there. Okay, so we have to maintain or we have to work this particular power plant must be near to this minimum heat rate value. Now another point is there, that is the incremental rate. Incremental rate means what? The rate at which input will increases as we increases the demand. Okay, so definition as we are going to see also there. Though the definition of the incremental rate is that it is the ratio of additional input required to increase the additional output. Okay, so it is the ratio of additional input required to increase the additional output. Now consider there is a 10 kilowatt or 10 units electricity generated, and I want to increase this output to the 12 units. Okay, now to increase the 2 units, how much amount of input we have to increase? Means I want to increase 2 units of output. For increment in the 2 units of output, how much input I required, how much additional input I required, that ratio is known as the incremental rate. And you can also see this incremental rate graph. This one is the incremental rate graph, and as we saw, as output has been increases, this incremental rate is also going to be increases. Okay, and when it crosses the heat rate at this particular point, this is the point where we have to run the particular power plant. Okay, this is the most efficient point or point which is having the maximum efficiency. Okay, so these are the performance and operational characteristics of the power plant. These characteristics are also going to be changes with respect to type of generator we are using, with respect to type of power plant, with respect to the loads and demand, etc. There are many factors, but generally those are be drawn by using the input and output requirement. Okay. Now the plant performance, the total efficiency, total heat rate is again we can calculate by using different formulas. The total input output relation we can find out or we can write down like this by this particular formula, that is I is equal to A plus B into L plus C into L square plus D into L cube. Now L means output, I means input, and all those factors A, B, C, D, those are the constant. Now, by using these particular formulas, you can calculate the input required for the particular output. The efficiency and heat rate formula you already know. Incremental rate, that is also you got. Okay, and at the particular when we require the less heat required, or we can say the at minimum heat rate, the uh, uh, the particular incremental rate is also given by this particular formula. Okay, so when heat rate is minimum, the incremental rate and heat rate will be the equivalent. Okay, so by using this difference formula, you can also calculate these particular factors, which are very important whenever we find out the performance and the operational characteristics of the power plant. Okay, so this is regarding the operational characteristics. The third point, today's point is economic division between the base load and the peak load power plant. Now, as we know, the base load and peak load, you have idea regarding it. Means if you consider there is a load which you have to carry it out by the particular power plant. Now, in that case, we can design the two power plants. One is a base load power plant and another is a peak load power plant. Base load power plant means it will always in the running condition. It is always take some base load. Okay. Whereas peak load power plant, it is only working whenever the demand is at the peak time, or the load requirement is at the peak. Okay. So that variation, for that variation, we are using these two different power plants. Now, if you want to divide the load requirement or the economics related to the in between these two power plants, we have to study the economical division between those two power plants. Okay, so in the designing of the generation plant, the economy has the prime importance. As we know, we are mostly designing the power plant by keeping in mind the economy is the important. Okay, also the efficiency is important, but mostly in today's world, we give more importance to the economy, right? The major problem for the power engineer is to economically distribution between the output of the generator, because there are two generators are available. One which is in the base load, another one it is in the peak load. So how to divide the load between these two power plants or the two generators? That is the main problem, and also the economic distribution between those two power plants, because the two power plants will have two different generators, each generator having different efficiency, each generator having different operational characteristics. Means the if we changes the load on that particular generator, it will giving the different efficiency. The variation is of different efficiency is different. Similarly, another generator which is in the peak load, it is having different or variation of efficiency is a different one. So whenever we divide the load between these two load or power plants, it is very difficult to achieve that achieve that distribution. Okay, so for that economic division is very important. Economic analysis of that particular two power plants is very important. So the proper division of load between two generations is to give maximum overall efficiency is the major problem, because we have to consider the maximum overall efficiency, not just individual efficiency of the power plant. Okay, because as a whole, this is the one power plant. It will consist the base load and peak load generators. Okay, when we combine all those power plants, the overall efficiency we have to consider. And if that overall efficiency is the maximum, then the power generation cost or the electricity cost will be the minimum. So for that, we have to consider or we have to study or analyze this economic division between the base load and peak load power plant. Now you can see here on the right hand side, there is a graph which will give you the variation of input required for the plant 1 and plant 2 with respect to the load. Okay, as load increases, the variation or requirement in the input has been given. Now you can see easily from this one, you will see at the one particular load, consider that much of load, the input required for the unit B is high than the unit A. Okay, so for A generator, the requirement, input requirement is less than the B generator. Means what? The A generator is more efficient than the unit B. So in that case, we have to most of the load has been given on the unit number A rather than unit B. Okay, so it will indicate that A is more efficient than the B throughout its load range, as the output of A is more than the output of B for the same input. Therefore, it will be common tendency to load A first to its full capacity, and then remaining load has been given to the load or the unit number B. Now, this is not a proper distribution because as we are going to take this decision based upon the efficiency. But what about the other factors? Because even if we give the maximum measure of the majority of the load to the unit A, it doesn't give you the maximum overall efficiency. Okay, so the distribution of the load based upon the efficiency only on the efficiency is not sufficient. We have to consider the overall efficiency. Okay, so for that we can use the different methods. So based upon that we are going to find out first of all the overall efficiency, and based upon the overall efficiency we are going to decide how to distribute the load. Okay, now you can again see this particular variation or the graph or the curve based upon the different distribution of the load. Now, first graph that you can see, consider there is a requirement is the 4 megawatts. Okay, so we are going to distribute this load in between two different power plants. Okay, and this curve you can see, this is the overall efficiency curve, or we can say the combined input versus load curve. Okay, now you can see the first curve having maximum efficiency, second curve having less efficiency, third curve having less efficiency. Okay, and this curve dotted line you can see, that is the dotted line which will give you the locus on the for particular unit number A. Okay, so consider if you divide this 4 megawatts into 2 plus 2 megawatts. Okay, 2 megawatts will given to the A and 2 megawatts given to the B. So in that case, this will be the curve. Okay, this will be the curve. Okay, and this particular point where minimum input will require, that is means it is the point where we get the maximum overall efficiency. So just keep in mind that whenever we divide the load, you doesn't have to mostly concentrate on the individual efficiency, rather than we have to mostly concentrate on the overall efficiency of the power plant. Okay, not just a single individual efficiency of that particular base load power plant or the peak load power plant. We have to consider the overall efficiency that is the given here. So the condition for this minimum input, it has been obtained by using this particular formula, that is the the change in the input divided by change in the load is equal to minus change in the input in the case of B, and change in the load in the case of for B power plant. Okay, so by using this particular formula you can also calculate the condition for the minimum input for the combined power plant. Okay, combined type of a power plant. So this is the economic division of between base load and peak load. The numericals we are not going to, there will be no any numericals based upon these three factors or these 3 points which we saw in this particular lecture. Okay, so these three are important points whenever we going to construct any particular power plant, because these are the operational characteristics of the power plant, and we have to study those characteristics, and based upon that we are going to plan or construct the particular power plant. Okay, so in the next lecture we will stop here. In the next lecture we are going to see the last point of this particular chapter, that is the tariff method. how the tariff will be calculated, and what are the different methods through which we can calculate the tariff, and also the numerical based upon the tariff method. For your MSc, only numericals based upon two points are there. One is the based upon load curve and load duration curve, and second will be on tariff method. Okay. So one first will be based upon we have to calculate the different factors. Those factors we already saw: diversity factor, capacity factor, etc. Another numericals will be based upon load curve or load duration curve. Okay. And the third type of numericals which is based upon tariff methods. Only uh, the numericals which are based upon those points will be there in MSc. Okay. The numericals based upon economic distribution or operational characteristics, there will be no any numericals. Only numericals will be based upon these three particular points. Okay. So we will stop here. If anybody have any doubt, you can ask now.